So the next step after we've done the law of sines is we have to explore a thing called the ambiguous case of the law of sines. What happens is if you're given two sides and a non-included angle, there's a possibility that no solution exists or two solutions exist, as well as the one solution exists. So when you're doing the law of sines, if you're given two angles and one of the sides opposite, you can solve using the law of sines and there's no problem. But if you're given two sides and the non-included angle, that's called the ambiguous case. So two sides of a triangle are given and the non-included angle. Now, what we'll do is we'll explore the different possibilities on this. We'll still use the same formula for the law of sines, that proportion that we set up, but let's talk about the different possibilities. You can either get one answer, no answer, or two answers. You get one answer in two different possibilities. The first one is when the given angle, even if it's not included, if it's an obtuse angle, so the given angle is obtuse, then you only get one answer and you just go ahead and use the law of sines and you'll get your one answer. If also you're given, if the angle you're working with is an acute angle and the side opposite it is the larger of the two sides, you're all set, just one solution. So side opposite an acute angle given is the larger of the two given. So that case also, if it's side-side angle, but the one, for instance, if I'm given angle A, if the side opposite angle A, little a, is the larger of the two, say it's larger than C being given, then you only get one solution. You can go ahead and use the law of sines and you're all set. But what if, on the other hand, I'm given angle A as an acute angle, and I'm given that side opposite it is shorter than the two, of the two. That's the one that we have to be careful of. Also, what if it's equal to it? That's when we get no answer. So when we look at this, we either have the side opposite is shorter. We have to examine this possibility, or equal. If it's equal, we know immediately that there's not going to be any solution. Let me draw what I mean by that. If this is angle A given to us, angle A is 50 degrees, and we have that this side here, side C is 10, and side A is just a 4, what happens is it dangles here, and it can't reach the other side. So let's set up the law of sines just to check that out. If I have sine of 50 over the 4 equal to sine of, we'll call this angle C over here, sine of C over the 10, let's do our cross multiplication and solve. Sine of C is going to equal 10 times sine of 50 over 4. Now when we break out our calculator and try that, what we get for that is 10 times sine of 50 divided by 4. What I get for an answer for that is that sine of C is equal to 1.915, etc. Now, if that number's larger than 1, when we take the inverse sine of that, so I take the inverse sine by trying to figure out what the angle is, angle C, inverse sine of that value, what I get is that there's an error. You're not allowed, you can't do that. So what happens here is that this type of answer means that there's no answer to this possible problem. And that's the result is because this side here is too short to actually swing and hit the other side here. It never gets there. So let's talk about what happens if we can get possibly two answers. This also is when the side opposite is shorter in this case, not equal, but shorter. So this, notice that this side opposite that angle A is shorter than the other side given, okay? The drawing of that would look like this, very similar. We would have a 50-degree angle here, and we would have this side here, side C being 5, so that's over here, and then this side over here being 4. Okay, so this is angle A, side C. We're going to figure out what angle C is. So let's go ahead and calculate this one. If we get this, we get sine of 50 over 4 equals our sine of C over 5. If we do our cross multiplication to solve, we get sine of C, and actually just multiply by 5 on both sides, equals 5 times the sine of 50 over 4. Let's see what that gives us when we do that. So when we calculate that, we get 5 times sine of 50 divided by 4, and we get sine of C equal to 0.9575, and it keeps going with more 5s, etc. Now when we look at that we can take the inverse sine of. I'm going to take inverse sine of that answer, and I get that C, when I do that, inverse sine of both sides, I get 73.24685, etc. Okay? And so I'll just say that C then is about, I'm going to just round to the nearest degree, so I'm going to make that 73 degrees. Okay? Now, that angle 73 kind of makes sense. But what I'm telling you is that there's a possibility of there being another triangle listed here, and let me show you what I mean by that. If I have my 50-degree angle here, okay, and this side is 5, and this side 4, if I take that side and I swing it over here, and if it swings over to the other side here, let me try that again here, if it swings over here, I could have a side inside of here that's 4, because it's the shorter of the two. And it fits. This one wasn't long enough to hit when that was a 10, but here when it's a 5, it can not only hit on this side, but it can swing over, and this side being 5, this angle being 50, that side 4 is a possibility also. Well, the question is, how do I calculate? I'm going to get rid of the 50 here, just put it down in the corner. How do I calculate if this, remember this angle here was a 73, how do I calculate what this angle is here? How do I get that second possibility for angle C down here? Well, notice that this 4, 4 is an isosceles triangle. That makes it, this is 73 here also, so that angle right there would be 180 minus 73, which would give us 107 for the second possibility for the angle. So we have two possibilities. We have this first angle of 73 degrees. We have the second angle of 107. We'd have to use both of them to calculate the rest of the missing information. So we'd have two cases, but we now have two solutions for that. So if you're given two sides and a non-included angle, you use the law of sines, but it's called the ambiguous case. If you have that given angle as being an obtuse angle, just go ahead, use the law of sines, you'll get one answer. If you have that angle being acute, but the side opposite is the larger of the two ones given, then you can go ahead and use the law of sines and you'll get your one answer. But if that angle is given, the side opposite it is the shorter of the two, then you've got to try two different possibilities. You could possibly have no answer, and that would come if you try to find out the missing angle and your calculator gives you an error because this number is larger than 1. Or the second possibility, notice that when we do it here, we get a number less than 1. You could get one answer, and then you do its supplement, and that supplement is also a possibility, and now you can use that information to get two answers to solve for the rest of the triangle. So we can solve the ambiguous case of the law of sines. We're given two sides and the non-included angle to find either one answer, no answer, or two answers, depending on the information given to us.